You know how these massive language models just keep getting bigger? Trained on, like, mountains of data?
Right, the standard approach.
Well, get this. There's a fascinating new way they're becoming significantly better after all that initial learning.
Mm-hmm.
It's almost like giving an already brilliant mind a turbo boost of understanding precisely when it's grappling with a complex problem.
Letting it find insights it might have missed before.
Exactly.
So what is this?
That's what we're diving into today. Our source is a research paper called Inference-Time Scaling for Generalist Reward Modeling.
Okay.
It's from researchers at DeepSeek AI and Tsinghua University.
Inference time scaling for generalist reward modeling. Okay, that's a mouthful. Let's break that down.
Yeah, let's do that. In essence, we're talking about boosting how these large language models assess the quality of their own answers,
Okay.
and even the answers of other AI. But crucially, not during the initial training phase.
Right.
It happens while they're actively generating responses for you. That's the inference time part. Gotcha. So when you're using it.
Exactly. And this paper introduces a really novel approach they call self-principled critique tuning, or SPCT for short.
SPCT.
Okay.
So the goal of this deep dive, then, is to figure out how this SPCT thing helps LLMs give better, more nuanced rewards, these sort of internal quality scores.
Precisely that. Understanding how they make better judgments right when they're working.
And why should we, the listeners, care about this internal AI stuff?
Well, because this could be a really key step towards getting more insightful, more dependable responses from the AI you use.
Ah, okay.
Instead of being stuck with just what it learned way back during training, SPCT lets it do a more dynamic, context-aware evaluation as it goes.
Like it gets a sudden upgrade in reasoning, right when you need it most.
You could think of it like that, yeah. A boost in its judgment abilities on the fly.
Okay, interesting. Now, the paper talks about the challenge of reward modeling. Why is it actually so hard to get AI to judge its own work well? Especially for those really complex open-ended questions we often ask it.
Yeah, that's a great point. There's a big difference between, say, asking, what year did World War II end? Simple fact, right?
Clear answer.
Versus more general queries. In the real world, what makes an answer good can be, well, complex, it's multifaceted, nuanced, sometimes even a bit subjective.
Like asking for creative ideas or analysis.
Exactly. Asking for innovative marketing strategies, or maybe an insightful take on a current event. There's no single right answer database entry for that.
Mm-hmm.
The AI needs to weigh things like originality, coherence, relevance. And that's way harder than just looking up a fact.
That totally makes sense. We've all gotten those, bland or just unhelpful AI responses to tricky questions.
Right. So this reward modeling piece is really vital for moving past those limitations.
Okay. And you mentioned inference time versus training time scaling earlier. Can you maybe elaborate on that distinction a bit more?
Sure. So connecting this to the bigger picture.
Yeah.
Traditional scaling, most of the time, means throwing more data at the model, using more compute power, during its initial training, making the base model bigger and hopefully better.
Right. The bigger is better approach.
Kind of. But inference time scaling is different. It's about getting more capability out of a model that's already trained.
Oh.
Squeezing more performance out of it, specifically when it's being used at inference time.
Like tuning up a car you already own, rather than building a whole new, bigger car.
That's a good analogy, yeah. And SPCT is a technique specifically designed to make that inference time optimization, that tuning, much more effective.
Okay. And this SPCT, it builds on something called generative reward modeling, GRM.
Yeah.
What's special about that type of reward model?
So what's really useful about this specific type, point-wise generative reward modeling, or GRM, is its flexibility.
How so?
Well, unlike some other methods that might be stuck comparing just, say, two answers side by side, GRMs can handle evaluating single responses, or pairs, or even multiple different responses, all using a pretty consistent method.
And how does it give the reward?
That's the key bit. Instead of just spitting out a number like a score from 1 to 5,
Yeah.
GRMs generate textual critiques as the reward.
Ah, like actual words explaining it.
Exactly. So you get much richer feedback. It explains why a response is good or bad based on different criteria it's considering.
Okay, that sounds way more useful than just a number. It's like getting a mini review.
It is, yeah. Much more informative.
Now, the paper mentions using principles to guide this reward generation.
Mm-hmm.
What are these principles? Where do they come from?
Right. So the idea of using principles isn't totally new. It connects back to things like constitutional AI, where you might have predefined rules or a constitution the AI has to follow.
Okay, I've heard of that.
But what the DeepSeek researchers found was interesting. Simply letting the AI make up its own principles from scratch didn't seem to help that much on its own. But if they used carefully chosen or filtered principles, that significantly boosted the reward quality.
So the right principles, the right criteria, are really crucial for making good judgments.
It seems so. It sets the stage for why SPCT is designed the way it is.
Okay, so good principles matter, which brings us right to the core. Self-principled critique tuning, SPCT. What's the big idea here?
The really fundamental innovation with SPCT is that it lets the GRM learn to generate its own adaptive principles.
Its own principles.
Yes, and accurate critiques, all tailored specifically to the query and the responses it's looking at right then and there. That's the self-principled part.
Wow.
So instead of relying on a fixed list of rules, you gave it beforehand.
It figures out the relevant rules for this situation.
Exactly. It dynamically develops the principles it needs as it goes.
That sounds incredibly flexible. How does it actually learn to do that? Is it complicated?
Well, it uses a two-stage process. The first stage is called rejective fine-tuning. Think of this as like boot camp. It's an initial phase where the GRM learns the basic format, the structure, for making these principles and critiques. And it learns this across different input types: single answers, pairs, multiple answers.
Learning the ropes.
Sort of. And a key part here is a rejection strategy. If the rewards it generates don't line up well with some known ground truth reward, or if the task seems, frankly, too easy, it's encouraged to basically discard that attempt and try again. It learns by filtering out the bad or uninformative attempts.
Okay, learning by doing and learning what not to do. What's the second phase?
The second phase is called rule-based online RL. RL meaning reinforcement learning.
Reinforcement learning. Trial and error with rewards.
Exactly. So the model tries to generate principles and critiques, and it gets rewarded based on some simple rules. These rules basically check if the generated critiques are helping it correctly distinguish the better responses from the worse ones.
So the feedback loop helps it get better at generating useful evaluations.
Precisely. It refines its ability to generate principles and critiques that actually work well. And what's really key here, I think, is how SPCT views this whole principle generation thing.
How's that?
It sees it as an integral part of the reward generation process itself, not some separate step you do beforehand.
So the principle creation isn't detached.
Right, it's woven right in. This allows the principles to be much more context-dependent, tailored to the specific situation.
That makes a lot of sense. Instead of a one-size-fits-all checklist, the AI can develop custom criteria for each unique problem.
Okay, so how does this connect back to using more compute power at inference time, the inference-time scaling bit?
Good question. SPCT leverages that extra inference compute using a method called parallel sampling.
Parallel sampling, meaning?
Instead of the GRM generating just one set of principles and critiques for a given input, it generates multiple sets simultaneously in parallel.
Okay, like asking it to think about the problem from several different angles at once. That's a great way to put it. The core idea is that by having the model essentially think in parallel, generating multiple lines of reasoning and evaluation, it can potentially overcome the limitations or biases of just a single perspective and arrive at a more robust, more accurate overall judgment.
So you get multiple opinions, essentially, from the same model. Then what? How do you combine them?
Then comes the voting process. The multiple reward scores that come out of these different parallel evaluations are combined.
Averaged or...
It's a bit more sophisticated than just averaging, often involving weighting, but the goal is the same. Aggregate these diverse evaluations to get a final, more reliable overall assessment.
Okay.
And they even push this idea further with something called meta-reward modeling, guided voting, meta-RM.
Meta-RM. Wait, meta. Like a reward model for the reward model.
Yeah.
Evaluating the evaluators.
Exactly. That's precisely what it is. They train a separate, smaller model, the meta-RM, whose only job is to assess the quality of the principles and critiques being generated by the main GRM in those parallel samples. Seriously, that's meta.
It is. Think of it like this. The main GRM generates, say, 16 different evaluations in parallel, like 16 judges offering opinions.
Okay.
The meta-RM is like the chief justice who looks at all 16 opinions and decides, okay, opinions 3, 7, and 12 seem the most well-reasoned based on their quality, and gives them more weight in the final decision.
Wow. So it guides the voting by identifying the best internal evaluations.
Exactly. It gives more weight to the higher quality samples produced during parallel sampling, which leads to even better scaling performance. It makes the whole voting process smarter.
Okay, so we have SPCT, these two learning phases, the parallel sampling, the voting, and even this meta-RM layer. That sounds quite involved. What kind of results did they actually get? Did all this complexity pay off?
It seems so. The empirical results they report are quite compelling. They tested SPCT on several standard reward modeling benchmarks, like reward bench, PPE, RMB.
Okay, the usual suspects. Right. And the findings consistently show that SPCT significantly boosts both the quality and, crucially, the scalability of these generative reward models.
Meaning it actually got better the more compute they threw at it during inference?
Yes, exactly. It effectively used that extra inference compute,
Mhm.
and it generally outperformed existing methods, older scalar RMs, semi-scalar ones, and even other generative approaches.
So a real step up in judging quality. Could it compete with the really big models out there, the huge ones we hear about?
Well, this is where it gets particularly interesting. The model they trained with SPCT, called DeepSeek-GRM 27B.
27 billion parameters, still big, but not the absolute largest tier.
Right. But it achieved performance that was competitive with, and in some cases actually better than, much larger publicly available reward models, like Nematron 4 340B reward.
Wow, 340 billion. So the 27B held its own.
It did. And with inference time scaling, especially the meta-RM guided version, they showed it could even approach the performance levels of models like GPT-4o on some benchmarks.
That's seriously impressive. Getting that kind of quality without needing the absolute biggest model size.
And maybe even more striking, they found evidence suggesting that this inference time scaling with SPCT could actually lead to better performance gains than simply making the model bigger through more training data and parameters, what they call training time scaling.
Okay, hold on. So making a reasonably sized model smarter at inference time could be more effective than just making a massive model.
In some scenarios, based on their results, yes. It suggests that how effectively you use the model's capacity at inference time can be as important, or maybe even more important, than just raw size. They also noted that older scalar models often showed biases.
Biases.
Yeah, like being good at judging one type of task, say factual accuracy, but bad at another, like creativity. SPCTs seem to lead to more generalist reward generation, less biased across different task types.
Interesting. Okay, so pulling this all together, what are the key takeaways for our listeners? Why should they keep this SPCT method in mind?
I think the main takeaway is that SPCT represents a really significant step towards getting more reliable, more insightful LLMs.
Because they're better judges of quality.
Exactly. By improving how they evaluate information right when you're interacting with them, STCT offers a way to get more sophisticated AI responses. And maybe, just maybe, without needing these absolutely enormous, ever-growing models all the time.
So it's a path to smarter AI use, not just bigger AI.
Potentially, yes. And this core idea of self-generated adaptive principles, that's a really novel and, I think, powerful concept for guiding AI reasoning and judgment. It could lead to AI that's not just spitting out info, but is more discerning, more reliable in its assessments.
Okay, so just to recap for everyone, SDCT helps LLMs get better at judging their own work, and maybe others, right when they're being used at inference time. It learns to create its own relevant criteria, these principles and critiques, on the fly.
Mm-hmm.
And by generating multiple evaluations in parallel and cleverly combining them, possibly with that meta-RM helping out,
Right, the vote.
the model can reach a more accurate, more nuanced understanding of what makes a good response. And the bottom line for us users is potentially more reliable, more insightful information from the AI tools we might use every day,
That's a great summary. Exactly.
which I guess leads to a final thought to chew on.
Yeah.
Could methods like this, like SPCT, be the first steps towards AI that doesn't just give us information, but actually offers really insightful, well-reasoned evaluations? Almost like an intelligent peer or even a critic.
That's a fascinating question. What are the implications if AI gets really good at judging itself and judging other AIs? Does it accelerate improvement? Does it change how we trust AI?
Yeah, it definitely opens up some interesting possibilities and maybe some challenges too. Something for us all to think about as this technology keeps evolving so quickly.
Absolutely, and that's space to watch.
Definitely food for thought. And if you, our listeners, want to dive deeper into the technical details, we absolutely recommend checking out the source paper itself. It's titled Inference Time Scaling for Generalist Reward Modeling.
It's got all the charts and benchmark details for those interested.
A great resource for digging into this cutting-edge approach.